Very good. Very good morning, Professor Shahnaz. On behalf of Techno India NGR and IEEE Student Branch, Techno India NGR, I welcome you. And for the today's webinar, so in this our international webinar series, today's topic is deep learning for biomedical applications. Before going to start for this webinar, let me give a brief introduction to our speaker today. So our speaker today, Professor Celia Shahnaz, she is a senior member of IEEE, fellow of Institute of Engineers, Bangladesh, and she has received a PhD degree from Concordia University, Canada in 2009, and currently working as a professor at Department of Electrical and Electronics Engineering, I guess, yeah, at Bangladesh University of Engineering and Technology, Bangladesh. So, and she has published more than 120 international journal and conference papers. She is a recipient of a Canadian Commonwealth Scholarship for pursuing her PhD study in Canada, and Bangladesh Academy of Science Gold Medal for her contribution in science and technology. Her research interests includes the areas of deep learning, pattern recognition, machine learning for audio, video, biomedical, and power signals, and many other fields are there. So I hope and there are so many other achievements of the professor. I hope our attendees and participants will gain as much as they can, and there will be very good, this lecture will be very much helpful for them. So over to you, Professor, so we can start. Thank you.
Yes, Professor, just let me just tell that this week we are actually celebrating gender equality means week. So and obviously in this occasion, so you are the best person who are really an authority in the field of research in biomedical signal processing. So thank you so much for coming, and please over to you. Let's start. Thank you.
Thank you, Professor Prasun Chakraborty and Professor Yogendra Solanki. It's a great honor to be here. Actually, I am a fierce supporter of gender equity all the time. And throughout my whole life, I have been working very hard to ensure gender equity in all levels, in terms of education, in terms of technical skill development, in terms of getting social opportunity, humanitarian technology-based opportunity. Okay, and it's not only giving opportunities for women. When there is a women conference, I also invited the male supervisors. So it's a equity in both the cases. So I really appreciate the initiatives you have taken. It's a very good initiative, and I feel myself blessed to be the inaugural speaker for this Gender Equity Celebration Week. And of course, I hope through my lecture, I will be able to give a message to all that for gender equality for women, we can achieve by improving our technical skill only and by making us more competitive in this smart world. This is very, very important. Okay. So I always emphasize on women empowerment, not just giving power to them, but by inspiring them to do meaningful research activities, innovative activities, so that they can be recognized by others in terms of their merit only. So thank you once again for raising this very important issue. With that said, let me go to my presentation and share my screen. You can see the screen, right?
Yes, madam, yes, we can see.
Yes,
Yes.
Professor.
Okay. So actually, I must thank Techno India NGR Institute of Technology and the associate faculty members, including Professor Prasun Chakraborty, for arranging this webinar and for inviting me to be part of this great cause. So today's topic is deep learning for biomedical application. Maybe there is the internet connectivity slowness. Let me wait. Let me go to the next slide. It's moving to the next slide. What is important for, I want to say that every faculty, graduate student, and uh, any other member should be part of at least one technical society chapters in IEEE. Because in IEEE, we have more than 39 technical society and councils. I myself is a great honor be a founder and co-founder of 4 technical society chapters in our country, in our section. So this is Signal Processing Chapter, Robotics and Automation Society Chapter, Industrial Application Society Chapter, and Society on Social Implications of Technology Chapter. So apart from these 4, I'm deeply involved in research related to biomedical that belongs to Engineering and Medicine Biology Society chapter, and also Power and Energy Society chapter. Okay, so I'm waiting for the, have you given me a hosting capacity for sharing the slide? Because I'm entering, but it is not moving and going to the next slide. The slide is not changing.
Professor, I think you should share your entire computer screen, because I think you have shared the first page only. If you can recheck with the share settings.
Okay. Okay, let me share it again.
Just share, just click on share and select the desktop one, or yeah,
Of course, I'm doing that.
sure, ma'am. Yeah, now we can see your screen, PowerPoint. Yep.
Oh, now it's moving, right?
Yeah, right. Yes, ma'am.
Okay. Yes. So thank you for the humble introduction by Yogendra. So there are many more which I can share, that I am in academic research and innovation for around 20 years, among which more than 18 years as an IEEE volunteer. And I serve in 2020 member IEEE New Initiative Committee. I really request you to visit IEEE New Initiative Committee website and see the opportunities of writing project proposals for funding, and let me know how I can help you. I'm the founder of site group Flash in IEEE Bangladesh section, and this is a special interest group on humanity and technology. I also served as communications chair IEEE site steering committee for 2 years, and now in 2020 I'm serving as women in site working group. And since I'm deeply involved in research in SPS, I'm serving as 2020-22 member IEEE SPS Women in Signal Processing Committee. And many of our women are having more than 10 years experience, and many of our males also. But they don't know how to apply for senior member and how to elevate themselves for the senior member. It's a great opportunity that I serve as 2020 member IEEE Women in Engineering Senior Member Elevation Drive. As Power and Energy Society Women in Power Region 10 representative, I got the opportunity to connect with Power and Energy Society members of whole Asia Pacific, and share my technical knowledge and ideas about power and energy society. In Global Women in Engineering, I served as a chair of Women in Engineering Workshop Subcommittee, and that has given me an opportunity to organize or coordinate around 25 workshops around the whole world. And it is a great honor that I served as and I served as a Regent and WI chair, and also of the whole Asia Pacific. And also I'm the first chair of IEEE, first female chair of IEEE Bangladesh section. And it's a great honor. And I'm the founder of Women in Engineering of Bangladesh section. So these are not only not only the list of my IEEE positions. This is the list of list of commitment for which I'm here today to interact and share my technical knowledge uh, beyond borders. And I believe in power of networking and innovative ideas. You can see in the power and energy day celebration and IEEE day celebration, we have made a human chain written past day and women in engineering. Okay, and this is human chain in consisting of students, graduate students, young professional, women in engineering, women in engineering, I should say, industry expert, entrepreneurs, past chairs of the section, other section leaders. So these innovative ideas I follow in every part of my life, every step of my life. So before going to the research, I want to remind everyone uh, to have uh, to have to keep in mind the UN Sustainable Development Goals like no poverty, zero hunger, good health, well-being, quality education, gender equality, and many others, so that we can connect our research with one of the goals, so that we can ensure our research is not and our ensure that our research does not give facility only to a privileged person like you and me. It should support the billions of people lying in the pyramid structure who are needy for getting the support. So there it is an era of machine learning, and it is an era of deep learning. So one example of doing a research that supports some of the sustainable development goals, SDG, is the blood glucose estimation, because blood glucose estimation needed by many people, but we do not have superior or equal number of expertise and nurse compared to the patient. But regular monitoring and surveillance is a common issue, but usually it is done by in an invasive way, which has a way of getting injuries due to non-expert nurses and medical practitioners. That's why, along with my students, we have devised a non-invasive blood glucose estimation using multi-sensor based portable and wearable system. And it is also low cost, so that every person can buy it and we can wear it, and it can be portable. In that way, we can make technology and research scalable and sustainable to the local community. So I request you, all of you, can you hear me, right? I'm audible to all of you?
Yes, ma'am.
Okay, thank you. So I request you, all of you, to visit my Google Scholar citations, okay? Google Scholar citations, so to see the impact of my research. From 2013 to 2020, we are still half the way of 2020. If you look at the Google Scholar citations, you can see that the citations are every year increasing. So that gives me a hope that we are in the right direction and we have chosen topics that is useful to others and that have been cited by others. So this is important for the young generation. Choose a topic and also do research in topic and do such research so that people can cite it. Okay. So this is the highest cited paper of my research life along with my student who has finished his PhD from North Carolina State University, USA, now doing a job at ABB in United States. And we have still research collaboration. If you look at the citation from 2012 to 2020, still people are citing it. And that is a very good topic. ECG, you know, it is a cardiac signal, electrical activity of a cardiac signal. And we usually gather ECG by ECG lead. But while we are gathering, it has a lot of noises. So denoising of ECG signal is of significant importance so that we can use those ECG signals for automatic detection of ECG disease and ECG arrhythmias and make the diagnosis faster. Okay. Let me see another because bilirubin level quantification and jaundice detection. Neonatal jaundice is a common phenomenon, but taking blood in an invasive way from a child is a very troublesome process, and majority cases it creates a lot of rashes and injuries. To avoid it, we have proposed a non-invasive structure and non-invasive way of bilirubin level quantification and jaundice detection by sclera image processing. That means we will take the image of the sclera, we'll find the yellowness of the eye. From that yellowness, we can determine the bilirubin level and we can find whether jaundice is there or not. Actually, my students are not mechanical engineering students, but still, I thank them for making this structure, which is easily portable, can be placed in a community clinic very easily, and children with their mother can come and give the image, and that image can be processed and decision can be given very accurately. And also, I must tell you, majority of the people nowadays are interested about machine learning and also about deep learning. And there is a problem we are suffering with deaf and dumb community because these are the people who cannot actually speak. So their language is sign language. But if you search sign language, majority of them are in English. But you know, I belong to a nation that has fought for language. 21st February 1952. So to support our community, I, along with my students, have developed these image-based Bengali Sign Language alphabet recognition for deaf and dumb community so that Using this Bengali sign, that means working with the Deaf Association of Bangladesh, our students have developed this sign database. And if we can uh, identify that which alphabet it is representing, then there is a scope that in the long run we can develop an interface that will help this person to order a book in the library or to order a food in the canteen. That is very, very important to ensure education, entertainment, and accessibility of such community. So let us focus today other biomedical signals such as musculoskeletal radiographs. This is an image, and abnormality detection from musculoskeletal radiographs is of superior significance. And our students have developed a deep neural network called CAPSULE network to handle this problem. And why we are motivated to do this work? Because 1.7 billion people having musculoskeletal abnormalities. If doctors depend on the radiographs only, and there is a chance that error in the decision may occur. But if we give them an automatic detection process, that will help to accelerate the diagnosis process, okay? And also the deep neural networks such as convolutional neural network has many shortcomings. That actually inspired us to investigate the capability of Capsnet in detecting musculoskeletal abnormality. So let us know what are the limitations of CNN. It has poor translational invariance and lack of information about orientation. And also it has travel when subjects are rotated and when lighting conditions are changed. Not only that, it needs huge data set for training, but always huge data set is not available for training. That's why our proposed CAPSNet is overcomes the following problems. How? The output from each neuron is replaced by a vector, and max pooling operation is replaced by more effective routing by agreement algorithm. Output vector of a capsule represent the probability that the entity represented by the capsule is present in the current input. And ultimately, class capsule determines the correct output level. So these are the advantages, and this is the way CAPSNet overcomes the conventional problems of CNN. And this is the overall structure. We'll have input, pre-processing, convolution 1, primary capsule, convolution 2, and there is optimization. Then class capsule will give you the output. And this is pre-processing because our data set contains image of variable sizes. So we propose to resize the images such as 64 cross 64, 128 cross 128, 224 cross 224. And you can see the results A, 64 cross 64, 128 cross 28B, and C is 224 cross 224. And you can see downsample degrades the image quality, but if we increase the pixel size, the more features are included and it avoids deblurring. And not only this subjective evaluation, we have also given an objective evaluation in terms of accuracy. If you look at the training, sorry, somebody is speaking. If you look at the training and validation accuracy of different sizes, and you can see for 2 to 4 cross 2 to 4 image size, the training and validation accuracy is higher. Excuse me, somebody is speaking. Please mute yourself. And also there are blind image spatial quality evaluator, BRISC, and natural image quality evaluator, NIC score. And if you can see, both the NIC score and BRISC score are smaller for 2 to 4 cross 2 to 4. That means lower the BRISC and NIC score, the more probability of preserving the important features after resizing. So this is the proposed structure. The convolution 1 has 256 9 cross 9 convolutional kernels, and convolutional capsule layer as 32 channels of convolutional 80 capsules. And class capsule includes 2 capsules, and each capsule has a dimension of 2. So you can see it, that image, convolution 1, convolution 2. Then we have applied routing by agreement algorithm, and then we get the capsule where there is a decision whether it is normal or abnormal. This is the data set. We have contained Mura data set containing 14,656 images, among which 8,941 images are normal, 507,715 images are abnormal. And you can see an abnormal elbow at A and a normal elbow at B. And we have to detect this abnormality through an automatic detection process using Capsnet. So this is a comparison by routing algorithm. If we vary the routing algorithm in x-axis, and if we plot training and validation accuracy, training accuracy by black, validation accuracy by red, we can see that if we improve the number of routing, the accuracy increases. But for some of the images, we have plotted images for finger, elbow, hand, humerus, forearm, shower, and wrist. For some of the images like C and F, if we try to increase the routing more than 4, then data overfitting occurs. To avoid data overfitting, we have decided to take 4 routing. This is the rationale behind choosing the number of routing. Now it is time to find how effective our proposed capsule network is. We have done it in terms of a Cohen-Kappa statistic score, and it is more robust. And you can see that kappa static score for Mura dataset using DenseNet is 70.5% on average for all types of images. And at the same time, kappa static score for Mura dataset using our proposed Capsnet is 80.115%. So that gives that our proposed Capsnet has better inter-rater agreement for qualitative evaluation. So this is the bar graph. It is shown in bar graph. Blue is DenseNet, and green is Capsnet, and x-axis all images are shown. An important claim here, the proposed Capsnet architecture provides almost 10% better kappa score than the 169 layers of DenseNet while using 50% less training data. So use of less training data but resulting in better kappa score is an important claim. Now here is our result. We have compared our result with a comparison paper that have used the Mura dataset. Please look the training accuracy and testing accuracy here for all images. And then if we go to the next slide, training accuracy and testing accuracy, using 4 routing in Mura dataset and using DenseNet for all images, training accuracy and testing accuracy have been increased compared to the previous slide. So this is an important claim. And another is loss accuracy graph. We have plotted loss accuracy graph for all images of Mura data set. The red one is the accuracy for CAPSNet, and black one is the loss of CAPSNet. Blue one is the accuracy of the CAPSNet, and purple one is the loss of CAPSNet. We can see that our proposed CAPSNet with respect to the number of iteration gives more accuracy and less loss. Whereas for DenseNet, the accuracy is less, but loss is high. This is very important claim, and this is an automatic, I should say, this is an important visible outcome that my students have published it in IEEE Access with impact factor more than 4 in 2019. And this is really a very important thing because he is an undergrad thesis student, okay? For undergrad thesis student, publishing a research outcome in IEEE Access is a huge achievement. Hope it will help him to secure his PhD admission in the United States or any North American good schools. Let us think about the skin cancer, because in Bangladesh we have 51 student branches, and I had the opportunity to visit in the rural areas, and I found that there are a lot of women and children who are vulnerable group is suffering from the skin cancer, but they don't really bother and they don't feel the importance of treating it. So we thought that why don't you take the images and do image processing using deep learning and find automatically that what type of skin cancer it is. And that will help the doctors to take the decision making faster, because usually what they do, they look into the image or they look into the skin and then they try to make the decision. Sometimes it becomes not accurate and treatment becomes wrong. So this is the data set we have used, HAM 1000, 10,000, and this is the class, 7-class classification. This is not 2-class like the previous research. The previous research was 2-class, normal or abnormal. But here you can see there are 7 types of cancers. So it is a difficult problem to handle. Dermatofibrosis, vascular lesion, and you can see melanoma as the highest number of images. That means there is a kind of data imbalance in this database, and there is a chance that even if it is vascular lesion, it can classify itself as a melanoma because there is huge number of melanoma images. To overcome this problem, we have employed data augmentation from the augmentation library. Types of augmentation is zoom, flip left right, flip top bottom, rotate, random distortion, skewness with different probability factors. Actually, this is the transfer learning. We will take input, then we will take convolutional base for feature extraction, and the features will be sending to the classifier for image classification and getting the decision. So this is the architecture of a model based on CNN, okay, convolutional neural network. But there are fine tuning strategies. If strategy 1 is train the entire model, and strategy 2 is train some layers and leave the others frozen. Strategy 3 is freeze the convolutional base. Okay, so these are the different strategies, but there is a trade-off and to decide and adopt the strategies based on the database. If the database is large and different from the pre-trained model set, then we must train the entire model. If the data set is large and similar to the pre-trained model data set, then we must train some layers and leave others frozen. And if the data set is small and different than the pre-trained model, then we train some layers and leave others frozen. And uh, and when the data set is small and similar to the previous train models, then we can freeze the convolutional base. So this is very important to get good results, okay? And these are the applied models: Inception V3, VGG16, VGG19, ResNet 50, and convolutional features, because there are many features such as uh, color plane, histogram, image quality, and a typical model architecture is Inception V3, and that you can see different layers, convolutional layers, average pool, max pool, concatenation, dropout, fully connected, soft max, and you can see the input and output. And this is just the structure of Inception V3. For top layer specification for all models, we have global average pool layer, dropout layer, batch normalization layer, and dense layer. So that's why this is our specification, and these are the conventional feature, as I said earlier: color feature, image quality feature, and there are histogram based features in different color domains such as RGB, hue, saturation, and then YCBCR. So these are the different color paints where we can do histogram analysis. And if we look at the accuracy, that compared to the conventional features, our Inception V3 and BGG16, um, VGG16, VGG16 is giving a better result compared to the compared to the accuracy. So we have analyzed the result and found that different networks work better for different stages. So we can take the best stage and then ensemble the decisions, and then we can apply it for classification. So this is a future proposal, that we are finding the best layer from each model, and then we will do fusion of layers. That means we will take decision fusion, and we'll send it to the classifier to get a right class. So these are some opportunities that I have taken in my section along with my team. Please visit IEEE Signal Processing website to know about Signal Processing Winter School. $5,000 you can get, but you need to have a SPS chapter. And we did it, and it was very successful to train our students, young professional women in engineering members, for machine learning and deep learning and other signal processing application. And this is a collaboration between Signal Processing chapter and our IEEE section. I was the founder of SpeaksCon, and we can do this conference in collaboration with your university. And this is between EMBS and section IEEE BasicCon. It's a great honor that I'm the founder of this also. And we really need to know about the implications of applying deep learning and AI to technology. To know such implications, we have organized this symposium under SSIT, Society on Social Implications on Technology. It was a great training, and many speakers from 5 different countries participated here. And it is important to have industrial collaboration with all technical society chapters. That's why we have called CEOs of top telcos, machine learning companies, power companies, and other ICT and smart device related companies, so that we know what are the industry needs and how we can develop our research for industrial use. And also women to women empowerment challenge. It is a IEEE humanitarian activity committee funded event where actually women have identified one problem of Bangladesh and provided technical solutions based on different technical knowledge in robotics and automation, in machine learning, in signal processing, in medicine and biology. So it is a great learning for our women engineers because you are telling about the gender equity, and actually it will help them to launch as a social entrepreneur so that they can serve the rural community where there are billions of people who really need help to solve their problem. Okay. And IEEE EMBS Bangladesh chapter have received 2020 IEEE EMBS Regional Outstanding Chapter Award. Thanks to the volunteers, I'm sharing this chapter in 2020. Thanks to the hardworking volunteer to set a good vision and implement the techniques. These are some of my individual awards. 2013 WA Professional Volunteer Award from Region 10, Asia Pacific. 2015 W Inspiring Member Award from Global WI. 2016 MGA Leadership Award. 2019 Region 10 Outstanding Activities Volunteer Award. And I must say, since the gender equality came, so the WI Women in Engineering section, for which I was the founder, and now I'm the advisor, they have won the Best Women in Engineering Section Award from Asia Pacific and also from the whole world. And the Women in Engineering Student Branch, for which I'm the founder faculty advisor, they became the best in Asia Pacific and became the best in whole region, whole world. So this achievement, staying in Bangladesh, is possible because of the hard work, myself as a chair, and also to lead a group of volunteers who are very talented and ready to embrace change. And it is a great honor that as a first female chair, in 25 years, I had the opportunity to receive the 25-year celebration banner from the Region 10 director that has driven me to do more technical activities, professional, industrial activities, women empowerment and humanitarian technology-based activities. And we really did. I led the full application as a chair and own 2018 IEEE MG Outstanding Large Section Award is a great honor. It has been awarded in Region 10 Congress 2018 Bali, and it is a great honor to receive the Best Women in Engineering Student Branch Award, Best Young Professional Award, Best Student Award for my community, for whom I really guided them starting from the idea generation to the implementation and reporting. It is a great honor to receive such awards from IEEE President, IEEE Future President, Region 10 Director, Past Director, and Future Director. It's a great honor. Actually, our uh, uh, this was the biggest challenge. This was the biggest challenge we can feel that we got the opportunity to handle IEEE 10 SIM 2020, which is a Region 10 flagship conference. During the pandemic, we handled it virtually, such a big conference. More than 1,000 papers were submitted and around 446 papers were presented, 44 speakers. It's a great honor to serve as a general chair of the conference, and it is the first fully virtual Region 10 flagship conference. It is a great role model for others. I'm happy to offer you help if you need it. And I also felt obligatory after 10 SIM to share the knowledge, expectations, challenges, and possible solutions in a full virtual conference with others compared to the traditional face-to-face technical conference so that the resources can be shared. So virtual conference organizers panel It was the first panel in the Asia Pacific to explore the challenges of organizing a full virtual technical conference, and it is an initiative, a post-conference initiative for conference organizers after TENSIM 2020. So I must say that it is important to have spirit. It is important to do hard work. It is important to have vision. It is important to deliver the responsibilities properly when you are in a student branch, when you are in a student branch chapter, when you are in a student section, and also in a region 10 or in global communities. Commitment is important. Implementation of vision is important, and readiness to serve the world is important. And I really never questions my readiness. I'm always prepared to lead the smart world, and I'm really honored to receive your help in this regard. And thank you very much for the invitation.
Outstanding lecture, Professor, outstanding lecture. I would like to tell all the young faculty members, researchers, that please go through the website. Please read the outstanding research papers, because she has research papers in many top journals of repute with high impact factor. So please go through her papers. If you get some idea, it will be beneficial for you. Also in your own papers, please cite her papers. Okay, so in that way, and because she is really an authority in the field of biomedical image processing, and in Bangladesh she is very well known, and also in foreign countries, Canada and all, and in IEEE, we pray to God so that she emerge as the director-elect of 2021. So it is our wishes to you, madam, because you have made so much contribution for IEEE in Bangladesh that you really deserve that post. So we are all with you and we'll support your petition. Don't do it. So now, Professor Yogendra, please you conduct the session if there are any question and answer session.
1 minute. Actually, it is our responsibility to tell the participants about other candidates also. So apart from myself, there are other candidates from Thailand, Dr. Supavadi, and Lance Tang from Australia, and Nurliza Noor from Malaysia. And it is, I request you to visit all. It is a graceful activity as a candidate.
Actually, Professor Lance Fang also is my friend, and his lecture is also coming. Okay, he's very good. Murdoch University, from Murdoch University. So yes, he's a very good friend of mine. Okay, okay, yes, madam. Once again, best of luck to you from all of us.
We are all friends. No problem.
Yeah, yeah.
Yes.
Yeah. Okay, Yogendra sir, please carry on.
Thank you, sir. Thank you very much, sir. Let me see if there is any query from participants. So if any of the participants would like to ask some question, they can post their questions in the question answer tab, and we can ask. So is there any query from participants? Okay, so I think we have one query from Aaditya Maheshwari, sir. Sir, please.
Professor, as per in the biomedical things, see, I'm one of the PhD scholar, and I want to pursue my thesis with that some prototype of the device for the early prevention of thalassemia, or I can say breast cancer, right? So in that thing, if I procure one device and develop such a biomedical device, what is the process to get certified to have it use that medical device in the hospitals, or for the permission from the authorities or hospital authorities? How to certify those things from the authority, and what kind of standard we should take care about it?
Yes, actually, getting a device, developing a device and getting it implemented for your own community, you really need to test it with your patients with permission of your hospitals, and there should be a standard and testing regularity authority in your state. You should follow their guidelines first. Okay, and following their guidelines, try to test in your hospitals and try to validate it in your hospitals. And then your validation results may be also again checked by the authority, standardized authority. If they approve it, then you can marketize it. That's the normal procedure for any implementation. You know, you need to at first get permission from the authority, standardized authority, and permission from the hospital's head, chief of hospitals, and permission and ethical consent from the patients. Test it in a mass scale, and then analyze and do weighting of your testing to the testing authority and get it approved. Then you can marketize and brand it.
Thank you very
Yeah.
much. But the it is we are actually creating a models on the based on the previous data set of the patients, right? And based on that those data set, we develop such a predictive model. But to implement that predictive model with our own developed prototype device and implement that such device into the hospitals and make our doctors and authorities too comfortable or to understand that this device will work and will not create any hazards for the patients. So how to deal with that situation for the, you know, once I'll carry my device to the hospitals, and how to make them understand that it will work.
No, that's why from the very beginning of your research, a doctor should be involved. That you will develop the device, then you will go to them, then they will not be convinced.
Okay.
That's why in the very beginning of your research, you should involve a doctor so that he or she remains aware of your contribution or your motive or your purpose, your application from the very beginning. And every stage you can take the input of the doctor to improve your device. If you do it from the very beginning, then at the end, he will be partner of your research or she will be partner of our research. And then it will be very easy to convince it. So that's our problem in the whole subcontinent, that we cannot create a really an effective collaboration. Collaboration does not start suddenly in a day. Collaboration starts from the root level, you know. And if you create a long-lasting, I should say, involvement, obligation, agreement, then that doctor will be part of your research, okay? And that will improve your device, because we are implementing a device to the patients, and patients will be diagnosed by the doctors. So we really need to get the input of the doctor to improvise our device so that the device does not look new after you really build it, okay? So there is no scope to rebuild it and to redesign it. And going back to 4 years back of your PhD study. So that's why in the design process, you involve a doctor so that your design becomes user-friendly and it becomes practical and implementable to the patients and accepted by the others doctors community. Is it clear?
Thank you, ma'am.
On that note, I would like to thank Professor Shahnaz and for such a great session. So from behalf of Techno NGR family and IEEE student branch, I once again thank you a lot, and thanks, as I hope we will have such a collaborations in future also. Thank you so much, ma'am.
And convey my message to all your friends.
Thank you, ma'am.
That is my only request.
Also, ma'am,
Because
we would like to connect with our thesis for you. We'll send you the research paper for your kind seek information and all regarding the research. We'll share our research with you as well.
of course, of course. Any help, just let me know how I can help you. It should not be a one-day webinar. It should be a long lasting impact because I am very close to you. It will be easier, and it will be easier because we really know each other's culture very well. Knowing the culture is actually advancing in collaboration. That's why it is important to know the culture first to improve in research and innovation, and that makes our path easier and faster. Thank you.
Thank you very much.
Have a good day. Thank you.
Have a good day. Thanks to all participants and thanks to professors here for their extraordinary help. Take care.
Thank you.
Stay safe.